Welcome to Precalculus Concept 26C. Underneath trig functions of any angle, we are going to find a reference angle. So there's 4 boxes. Okay, let's first figure out what the heck even a reference angle is. So let me shrink this down for you. Okay, so I have 4 different little drawings here for you. Quadrant 1, 2, 3, and 4. And I'm going to give you a picture of what a reference angle is. So we're going to draw an angle in sort of standard position here in all of my little pictures here. So let's get ourselves and set ourselves up for success. Okay, so in quadrant number 1, if I draw an angle that terminates in quadrant number 1, then it could be something that looks like this. And the angle that I would create would be right there. In quadrant number 2, that means I would have an angle that would terminate like that, and I would have this angle theta here. If I was in quadrant number 3, then I would have this angle here, and that'd be angle theta. And of course, if I was in quadrant number 4, if I had an angle that terminated in quadrant 4, it would look like that. Okay, so the reference angle in quadrant 1 is actually the angle itself. So it's not very interesting in quadrant number 1. In quadrant number 2, the reference angle is located here between the terminal side of theta and the x-axis. So this is going to be our reference angle right here. In quadrant number 3, our reference angle is located here. Again, it's between the terminal side and the x-axis. And then in quadrant number 4, our reference angles are located here. Again, it's between the terminal side and the x-axis. Okay? So a reference angle is always 2 things. The first thing that a reference angle always is it is acute. Okay? What does that mean? That means that it's an angle that is less than 90. Okay? Or so it's in between 0 and 90. So it is always acute, and that means that would include that it's positive, right? It's always positive and acute, and it's always between the terminal side and the x-axis. All right, this is the important part. A lot of students sometimes make the mistake of drawing the reference angle, for example, this one here, right? But between the angle between the terminal side and the y-axis. That's not the case. A reference angle is always between the terminal side of your angle and the x-axis. So what a reference angle is it allows us to draw the right triangle in the appropriate quadrant and figure out all of the trig functions based on what quadrant it ends up being in. So this is the big idea for what a reference angle is, but for now, all we have to do is sort of figure out how to get them, okay? So that's box number 1 for you. Okay, let's do 3 examples together in box number 2. We're going to find the reference angle for each of the ones that I have before you. So A says 345 degrees. Okay, so let's go ahead and figure out where 345 degrees is if I draw it in standard position. So I would go all the way around once, and then I would go up a little bit more. Okay, so there is an angle of 345 degrees. So in quadrant number 1, I told you that the angle itself is between the terminal side and the x-axis. So that would be this angle here is the reference angle. So how do we get it? Well, it is the leftover part when I go all the way around 360 plus 345. So if I took 345 and I subtracted off 360, I'd have a 15-degree angle left over. So the reference angle would be 345. Okay, 5 pi over 6. So let's figure out where in the heck is 5 pi over 6. Okay, 5 pi over 6 is going to be over in quadrant number 3. Okay, so that'll be somewhere over here. So this is 5 pi over 6. Oh, excuse me. 5 pi over 6 is right here. My bad. Excuse me. Sorry about that. 5 pi over 6 over here is in quadrant number 2. Okay, so the reference angle in quadrant number 2 is the angle that's left over that's in between the terminal side and the x-axis. So you have to remember that this is equal to pi, right? And another way to represent pi is 6 pi over 6, and this angle is 5 pi over 6, so the part in the middle, the leftover part, is going to just be an angle of 1 pi over 6. So therefore, the reference angle that we were looking for is a value of pi over 6. Okay, part C, the reference angle for 2.5 radians. So 2.5 radians, you have to kind of figure out where in the heck is 2.5 radians, okay? Well, 2.5 radians is somewhere between pi over 2, which is 90 degrees, and pi, which is 180 degrees. So pi, or 2.5 radians, is somewhere over here in quadrant number 2, because this is pi radians, and remember pi radians is 3.14, and pi over 2 radians is approximately 1.57, and I'm looking for 2.5, so it's somewhere here in between. So how would we get this answer? Again, it's the same thing like in part B. It is the leftover angle that is between the terminal side and the x-axis. So what I would do is I would take 3.14 and I would subtract off about 2.5, and it would be roughly about 0.64 radians. So that is an acute angle, it's positive, and it is between the terminal side and the x-axis. So there you go. Okay, here's a U-try. Find the reference angle for theta equals 580 degrees. Okay, I hope you got the right answer of 40 degrees. The way that I did that was I took 580 and I went around one full revolution is 360. I did another revolution at half a revolution at 180, and then the leftover part would give me a 40-degree angle. So therefore, 580 degrees has a reference angle of 40 degrees in quadrant number 3. Okay, last one, box number 4. You try again. Find the reference angle for 8 pi over 3 radians. Okay, this one was a little bit tricky because you had to figure out that 8 pi over 3 is 6 pi over 3 plus 2 pi over 3. So that gets you all the way around the circle once, and then it gets you over there into quadrant number 2. But you are responsible for finding the part in between here. So the way that I did that was I took pi and I subtracted off the 2 pi over 3, changing pi to 3 pi over 3 minus 2 pi over 3 gave me the reference angle of 1 pi over 3.